as Andrew mentioned before, I've kind of had a role on a lot of different fronts within the Passivhaus world. I'm a Passivhaus consultant. I was previously with 475 High Performance Building Supply, where I did their daylighting sector. I also teach courses at RPI up in Troy, as well as CUNY in New York City. So kind of been in the passive world for the last 5 years. And as they mentioned before, it's been kind of New York centric with the NAPHN conference, and that's kind of the world I've lived in. And in the last couple of years, I've come out west and been really impressed by what you guys have been doing out there. So it's really exciting to see some of the strides. So with that being said, let me jump in here. I have a pretty packed presentation here with some case studies. It sounds like every pretty good understanding and pretty high level understanding of Passivhaus. So I am going to go into some of the basics of windows within a Passivhaus, but hopefully I'll kind of zoom through those and we can get to some of the juicy good stuff. So if anyone has any questions off the bat, I'm happy to take them. Otherwise, I'm going to get started. All right, good to go. So, if you do have anything that comes to your mind during the presentation, feel free to reach out. I'm happy to make it more conversational. If not, I can stick around after and take questions. All right. So I'd like to start off by showing this picture. This is kind of the holy grail of Passivhaus windows. This is my old boss, Ken Levinson's 2 children. And you can see that they are sitting up against this window in the dead of winter. And what do you notice? Look, they're very comfortable, no socks, right up against the glass. There's no radiator underneath this sill. It's just a well-performing window that's keeping all the conditioned air in the conditioned space. So it's really encompassing all the different things we want with our windows.
Ben, something that's important to note on this is there's snow actually building up on the exterior of the window, and it's not melting.
Yeah, why? That's a great. Why they're not melting? Because it's a high-performance triple pane window, and the warm air, the conditioned space, is not getting to that exterior pane of glass. Therefore, the snow isn't melting. So that's a good sign for a high-performance window. Thank you for that. So I'm going to go into kind of a general breakdown of what the presentation is going to cover. We're going to look at comfort and health within windows. We're going to take a quick look at orientation and shading. We're going to dive deep into the performance and the different components within a window. Then we're going to do a quick calculation, a little bit of energy balance. I'm not going to go too deep into the weeds on that. We're going to go look at some installation methods, different scenarios. We're going to look at some therm modeling examples, and then we're going to dive into the case studies. So first, let's start with the comfort drivers. So like any Passivhaus component, it's all about this continuous envelope. It's all about keeping everything as static as possible. So same thing with the windows. They're part of your envelope. They're trying to maintain this completely static interior space. So that's true for temperature being in the space, but also for lighting levels. You don't want to have disparate lighting levels where you're going from light to dark. That can be uncomfortable, or too much light from, let's say, a skylight might cause glare. So we want to keep everything as static and as even as possible. And when we're looking at these components, there are certain things that can cause discomfort or health concerns. Of course, if you have air leakage within your assembly, you have drafts and heat loss. So on the right, you can see this infrared image of the door. You see this dark purple spot is showing that there is, an air leak within that door. So not installed properly, and you're going to get that discomfort. Same thing with condensation. So here on the left, you can see an image of a skylight. What do you see? It looks like it's leaking. However, what's really happening in this is condensation. So you have this aluminum profile that probably has a thermal bridge right to the exterior. You have that warm air hitting there, condensing and dripping. So although it might seem like your roof is leaking, you call back the roofer, they're going to come and tell you, that's not an installation problem, that's a specification problem. It's not the right unit for the climate. And then, of course, overheating can also occur, and as I mentioned before, glare and lighting levels. So someone I follow on Twitter, Nick Grant, posting this in his office, that even though his office is at room temperature around 73 on a summer's day, he feels like he's baking out there. And you can see from the IR image that center of glass is very, very hot. So what's happening here is, even though the thermostat is giving you a constant temperature, because this is a poor performing window, it's acting as a radiator, and it's getting really hot, and it's radiating to the person there. So you can actually feel that coming off that. So we want to avoid this as much as possible. The U-glass really does matter. So this is kind of your typical double glazing here. And you can see we have the same scenario, an interior temperature at around 68 degrees. And we have an exterior temperature of fairly cold at 6 degrees. And what you see here is that although the rest is right from the window, we can see that drop, and it's at 59 degrees, so more than a 10 degree or less than a 10 degree swing, but still significant. And you're gonna feel that, that when you're in this space. That cold air is gonna suck the heat from you. It's this temperature asymmetry. So you don't wanna be in a space like this. It's all about having a static, consistent envelope. So here, if you look at the triple glazed Passivhaus window, you can see that that delta T in the temperature is way less, about 4 degrees. And keeping that as close as possible, you can see that you're going to be way more comfort. So traditional way, not comfortable. High performance Passivhaus, you're getting more and more comfortable. So the Passivhaus Institute has a comfort criteria, and that's that delta T, that swing between the temperatures. Minimum average surface no lower than 0.5 C than the average interior surface temperature. In degrees Fahrenheit, that's roughly 6, between 6 and 7. So you don't want to have more than a 7-degree difference from your surface temperatures, because you're going to feel that discomfort. And now, I've also mentioned health as a concern. Health is an interesting one. PHI kind of refers to health as a hygiene requirement. And what they do is they set this RFSI limit. And this is a number that makes sure that the minimum surface temperature on an interior surface is not at risk of condensation, and thus that avoids mold growth. So a closer look at what the FSRI is, it's a ratio. So we're looking at our minimum surface temperature here, which you get from a therm model or like. And you can see you have your minimum temperature at wherever it is here. You have 7 degrees C. Let's say it's 20 degrees outside, 10 degrees inside. You're going to take that minimum surface temperature. You're going to minus the exterior temperature, which would be -10. And then you're going to do the same for the interior temperature. Let's say it's at 20. You're going to do the same at -10. And that ratio is going to give you that number that I showed before. So in the cool temperate climate, which is in US terms about climate zone 5. And it sounds like you guys are from all over in different climate zones. So I think some of you are actually more in the climate zone 6. Is there anyone in climate zone 7 there? Probably somebody up in the mountains.
Yeah, Jackson is.
Cool, right. So you're gonna have a very hard time. It's gonna be a lot more challenging to get this criteria met. And I'm sure you've had experience with that.
There's a few spots in Colorado as well.
Yeah, it's funny because most of the projects I work on are mostly on the East Coast. I have done some West Coast projects, but again, I'm mostly in climate zones 4 and 5, so it's a little bit easier time. But these are those ratios if you want to refer to them. All right, so continuing in the theme of comfort, what's happening here? So this is on the west side of Manhattan. One of these lovely glass boxes. What you see is that you see all the shades are pulled down. So you have all this glass, but you're pulling down the shades. So what's the point? What you can see is that it's probably a comfort issue. They're probably getting way too hot, beating out through the day. So they're trying to prevent that from happening. When we're talking about Passivhaus, we want to talk about balanced fenestration. The windows are always the weakest point of your assembly, no matter what. So we want to limit them as much as possible. That being said, we still want to have like an architectural expression. We want to have the views. So these are fairly large punched openings. I think that's about 9 feet, that distance. So you get a lot of exposure, but you still have some opaque parts of your assembly. Your feet don't necessarily need the view. And then, of course, when we're talking about overheating, shading is essential, ideally from the exterior. And you guys are probably more familiar with shading tactics, so I'm not going to go too in depth, but there's tons of different louvers, brise-soleils, balconies, etc. And of course, shading is very effective. This is from the Passivhaus Institute. So the frequency of overheating events on the left here, so you can see, you know, just temporary shading. They're going to have a roller blind on the exterior, then they have it between the panes, and the absolute best is when you have an exterior roller blind. Sorry, I think I said that backwards. These are interior shading, which is less effective of blocking heat, and then you get to the exterior shading, and that reduces quite a bit. So now we're going to jump into the window performance, and there's a lot of different factors. Some of them I mentioned already, but we're going to look at orientation. We talked about shading. Then we're going to talk about the type of glass, so how much heat versus light gets through the glass assembly. And then the U value, of course, is what we looked at before. You know, what is the U value of the glass? Same thing with the frames. What is the U value of the frame? Then we're going to dive into the spacer and what that means both for the glass spacer and the install value. Air tightness is key in a Passivhaus envelope, and this is true for your windows as well. And then we're going to look at the installation and integration into your air tightness. So you can see here, these windows are in the assembly connected to their airtight layer, both exterior and interior versions. So specs and kind of break down a tip performance window. You're going to break it down into these 5 parts. The glass, like I mentioned, you have your U value and the different coatings that you can have on this glass. You then have the type of spacer that separates the panes of glass. You have the frame, ideally an insulated or over-insulated frame. You're going to have the air tightness of the unit itself, so gaskets along the operable sash. And then the installation, so how the window is installed and where it is installed. And all these components together, if you start to maximize them, you get to more of a Passivhaus certified unit. So let's start with kind of the light portion. So let's talk about energy and light. So light is cool because it's kind of groovy. It's got this duality, right? You get 2 things from it. You get energy from the electromagnetic spectrum, and you get visual light. So this light through the window, there's also heat coming through the window. Now, we can kind of take these 2 components and control them separately, although they are linked. We can block out some of the heat coming from the sun, but let in some of the light. So one way we block out heat is through the solar heat gain coefficient. So this is the fraction of incident solar radiation emitted through the window. Now this is a number between 0 and 1. 1 means that all the heat has gone through the window. 0 means none of it has. So in heating dominated climates, you know, the higher solar heat gain, the better, because you get that free heat from the sun. Of course, you want to try to couple this with shading so that you're not overheating. So there is this kind of connection between the solar heat gain and your visual transmittance. So here you can see, you know, what we call a solar heat gain coefficient ratio of 1, which is the same amount of heat coming through the glass as light. So if you wanted to reduce the amount of heat in this scenario, the old technology would be, if you remember those buildings in the 70s that had kind of those brown tinted glass, very ugly. It was like you were wearing sunglasses. That was more of the ratios around 1 and 1.2. Now we have way better glass. We can get to, you know, a ratio of 2, meaning we allow double the amount of light versus the amount of heat that comes into the glass. So think of that as like a 60-30 glass, 60% visual transmittance, 30% solar heat gain. And this is really important that, you know, that low solar heat gain for areas like skylights, let's say the very exposed areas, you want to limit the amount of heat that's coming through. And then there is a maximum theoretical about 2.5. For, you know, depending on the project, the sweet spot is around that 2 for the really low solar heat gain glass. So that was how much energy is coming through the window. from radiation, and now we're going to look at energy through the unit itself. So I know you guys have all memorized this equation, so I'm not going to go into it, but this is the Passivhaus window calculation. So what they're doing here, I know that this is a lot of letters and numbers here, but it's pretty straightforward when you start to break it down. What they do is they're taking the area of the glass and the U value of the glass, they're adding that to the area of the frame and the U value of the frame. And then they're also incorporating the spacer connection, so the area around the glass between the frame and the installation, so the SI install, which is the area where the window is being installed. And all of those get calculated together to get your total U window. So a little bit different and a little bit more specific when you get to the Passivhaus certification. And those SI values, those are those connections here at the spacer or at the install. Those are calculated in a separate software, not in the PHPP, but in something like Therm or Flixo. And pretty much what you're doing is you're calculating, you know that you have a U value for your glass and a U value for your frame. And what you do is you model the total assembly, and then you pretty much take the difference of the U glass and the U frame from the total modeled system, and you'll get your SI value, because heat will flow in the shortest way possible along, the easiest conductive path. And and what that will do is that'll change the isotherms, and heat will actually move quicker through here. So those SI values actually make a big difference when you're doing your thermal calculation. So this is different than other energy modeling softwares. The SI calculations get inputted into the PHPP. So very important. They do this for the SI spacer as well as your installed value. So the connection between the window frame itself and your wall system. So when you're doing a Passivhaus, you actually have to model this situation. And then the PHI, so the Passivhaus Institute, they have certified components. So these are the frame classes. And pretty much the frames are always going to be the weakest part in a window. You can see your typical window. This is the most heat loss. Even improved glazing, you still see it around the frame. And even when you're getting to the best, a Passivhaus glazing level, you can see that through the IR that you have this heat loss around the frames and around the install. So these letters kind of tell you how good they are. So you can see your, how good they have to be. So if you have a PHA plus, that's good pretty much for all climate zones. Good for 5, good for 4, maybe 5, depends. So that's pretty much, they give you kind of a baseline when you're shopping for materials. If your certificate says what frame class it is, it kind of gives you a sense of what you can use in what climate zone. So if you want to see those components in real life, this is a section of a window. This is an Austrian manufacturer. They have a thermally broken frame up top, or on the bottom, you can see it as well. So 2 sections with a thermal break material inside. Then you can see they have a triple pane IGU. And these are usually filled with gas, either argon or krypton, and that dimension will change based on the optimization of each glass. Here you can see they have the warm edge spacers there. You can see the desiccant falling out there. This window has an airtight gasket all the way around the frame. It's a turn window. Actually have 3 levels of 2, 3. The main one is always on the interior, or usually on the interior for these windows, because this one will get degraded from UV over time. And then the final thing is the installation. You can see that it's over insulated on the frame here. So you can see this, the sill is here, and then they have this molded high density foam that's acting as a sill plate that's over insulating the frame. So you want to over insulate the frame as much as possible, because you're limiting heat flow at that weak junction. So if anyone has not seen the PHPP, this is a screenshot from it. It is pretty much a giant Excel spreadsheet, and it tallies up all the different components in your building. It can be pretty intimidating, but when you walk through it step by step, it's pretty straightforward to use. So here, this is a screenshot from the heating and cooling tab. And what they're showing is pretty much the window orientation, how much radiation you're coming at each orientation. You have your shading factors at each spot. Dirt has a pretty much a fixed level. Where it is if it's perpendicular or horizontal, and so on and so forth. And pretty much what we're looking at is our solar heat gain. In Europe, the G value is your solar heat gain coefficient. You have your window value as well as your glazing area, so how large the windows are. And pretty much what we're doing is we're calculating this balance. So how much is getting lost through these areas versus how much is getting gained from the sun. And right here, you can see that our heat gains are larger than our heat losses. So the amount that is being lost through transmission through the window itself in that area. So in the winter, these are our radiators. So our south-facing windows are heating elements. So we really can utilize this free heat. And this PHPP really fine-tunes exactly how you can balance the windows and get it to work in your favor. So it's a little bit of a design play. You have to go back and forth with shading, with sizing, and then overall you can get to these really, really efficient assemblies. So now let's look at more of from an installation standpoint. Usually I give this as a quiz, but since most of you guys are muted, I think I'll just tell you the answer. The best installation is here in the center. And that's pretty much the key takeaway, is that your window is part of all of your layers. It's part of your watertight layer, it's part of your insulation layer, it's part of your air tightness layer, it's part of your vapor control layer. So you want it to be in line as much as possible with all those layers. So that's true for the insulation layer. You want it to be directly in the middle of your insulation layer. Once you start poking it, yeah?
Sorry to interrupt. I've seen these images in the past, and the values from the middle of the insulation layer versus the outside of the insulation is relatively small, and wanted to see if you had done some modeling where it had made a more significant impact to the overall performance.
Yeah, that's a great point, and I'm going to show it in some case study slides. Is of course this is best case scenario. If you're just doing the textbook, this is the way you install a window. But of course there's design considerations that you want to take into account. Sometimes it just, you need to put it in a certain area, and you can see from the U value that it is relatively minor. Although you can see in this situation, it's pretty bad. You would want to avoid this. So there
certainly
are
more, certainly more significant on the very interior, but from the middle to the outside, it's a relatively small delta.
Yeah, exactly. And a lot of times what you can do is you can compensate a little bit by over insulating the frame and get some of that back. But yeah, this is something, again, there's no Passivhaus police that's going to come and be like, no, have your window on the outside. So in your assessment, you're going to put this into your model and you can make it work for sure. You might have to compensate somewhere else. I mean, there is some significance here if you have a lot of windows, and over time that is a heat loss. So you would want to just incorporate it into your model and make them work. Yeah, thanks. Good question.
Thank you.
And then, so in that kind of vein of like installing the window in there, of course, you typically install this on blocking. It's got to be something that's hard. So this is a way to have kind of avoid that thermal bridge. This is, again, that high density foam, the window sitting directly on it. Then you would fill this area with, whatever insulation you're using to really wrap that entire window in a complete insulated blanket. And kind of a drawing version. So this is a good example of kind of like where you don't have a choice of where the window can go. This is on a historic project. We've got to keep that historic brick facade. Where do you locate the window? It's got to be there a lot of times for cultural reasons or landmarked preservation reasons. So what the best thing you can do is really try to wrap that insulation layer in and around the unit. And you can see here that these lines are showing complete continuity with your exterior, which is your weather tight layer, connected directly to the window. on the interior, your air tightness is ignited on the inside, and then as much insulation wrapping the unit as possible. And if you want to look at what that looks like in a real world setting, here it is. You have that exterior WRB taped right to the face, interior air tightness directly to this triple pane unit. The unit is sitting on additional insulation, and this is an I-joist wall assembly, and this whole cavity is filled with insulation as well. So continuous, 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 air tightness, WRB, insulation. All right, here's another quiz. Where's the weak spot? So, so this is an exit hatch. I believe this is in a photo taken in Maine. So you can see where the leaking is happening. And we'll walk through kind of how do you reduce that amount of that per assembly. So we're gonna look at it in a skylight lens, but this kind of will work on any orientation of a window. It could be a regular window, skylight, pitched window, doesn't matter. So here we're going to look at kind of that RFSI again. This is a project we're looking where we need a 0.7. If you're in a different climate zone, you may need it to be higher. But the problem here is that there's this upstand with absolutely no insulation. You have a really bad RFSI way below that 7, so it's not gonna fly. So let's beef it up a little bit. Let's get that frame extended, give us a little bit more insulation. Let's overshoot glass, try to compensate for that weak corner. What we did is we bumped up the interior surface here, but now our cold point is right at the corner. So really at the corners, especially with skylights, that's always gonna be your weakest point. It's where all the things are meeting, where the spacer meets the glass, meets the frame. So that's always gonna be a weak point. So here again, you see that we're still not cutting it. Get a little bit better. We have an insulated fiberglass upstand, over insulated frame. Still the weak point here is still below our value. This unit tries to compensate for that by, you see this little finned component here. That is a aluminum piece that acts like a little radiator, and it's trying to radiate some extra heat from the inside just to get that point above condensation. A trick for functionality, but it would not work in your Passivhaus criteria. So that's why you want to use Passivhaus certified components. So this is a Passivhaus certified skylight. You have a way bigger, beefier fiberglass upstand installed correctly within your roof insulation layer, even more insulation in the frame, around that. And now we've bumped our RFSI past the 7 point, and we have no condensation at this area at all. So completely thermal bridge free. And that can happen in a curtain wall system as well, or this is a curtain wall or skylight system, another Passivhaus unit where pretty much the triple pane IGUs are doing most of the work. And then there is an insulated thermal break here between the panes and a pressure cap that caps that all off.
Sorry, Ben.
No problem. Was that a question or no question?
No, sir.
All right, no problem. So yeah, so you can have that and all that in different modes. So I have about, I guess, 10 minutes left, and this is the case study part. So I don't know, Andrea or Lindsay, if you want to give me like a time to go through, if you guys want to open up to more questions, but I was going to walk through kind of the detailing of things and installation of things, but I don't want to take up too much time. So you guys let me know.
No, we've had many that went on for almost an hour and a half, so feel free to take it as you feel best. And yeah, and guys, ask questions too, feel free. So yeah, take it at your own pace, Ben.
Yeah, does anybody have any kind of questions on some of the, some of the points that he made, and just in terms of why the windows matter and how they factor in? I mean, I think even just from that, one of those first images you shared, Ben, with Ken's kids sitting next to the window, I think it just brings to light to things about windows that we all take for granted, and then you notice them in a particularly different way, and you realize how better most of our windows can perform. So, I mean, I don't know if there's any other general questions out there, but thought I'd give people a chance.
Well, I'd like to add just one thing in regards to the image that had the delta T on it. When there is a delta T of, I think it's greater than 7 degrees Fahrenheit, you end up with phenomena where you get a microclimate that manifests as a draft, people think their rooms are a little right in their living room, because what happens is the air along the wall or window surface drops, and the air within the ambient space beyond fills that gap, and it creates this swirling, if you will. And it's, I believe it's at a delta T of either 7 or 9 degrees where you start getting this draft, where it's not really a draft. It's really just a convection current that's happening right in your living room or your bedroom or wherever.
Yeah, Todd, that's a great point. It is at that 7 degrees, so that's kind of what the Passivhaus Institute is trying to accommodate to reduce is any of that discomfort. And that's another good point on, you know, bad building envelopes. Even in their design, it's not an installation issue. It's not an airtight leak. Just the specification can comfort. So you can call your builder as many times as you want, but saying, hey, my window's drafty, there's something wrong with it. But really, it's the spec of the actual window. It's not performing as best as it can.
Hey, Ben, I have a question. Maybe this can be resolved or discussed through your case studies, but what do you find is to be kind of the largest misunderstanding of windows? In other words, like I had just talked with a guy who wants to build at 6,700 feet near Aspen, and he's dealing with somebody in N-Rail, and the guy in N-Rail says, well, my modeling says that double pane windows are fine. And I was just, I just thought that was just nuts, that there's this deep misunderstanding between the relationship between energy and comfort. Personally, do you find similar things, or are there other things out there that drive you nuts?
Version 5.
What's that, David?
I feel like he's working off PHPP version 2.
It was, and this is, the voice of NRail, right? So
yeah. Well, I think it's a great point, and it's a larger discussion about how we deal with codes in this country and what is acceptable and what's limits. I mean, they're working off an assumption that Europe kind of had 30, 40 years ago, and we're still in that same state about our building codes, and depending on the municipality that you're in, it's pretty outlandish. I'm currently up in the Catskill Mountains in a very small village, and our building code is pretty much non-existent. I can do whatever I want as long as I have the baseline energy code requirements. So it's interesting mindset. I think, like you said, I heard Golden, Colorado's made huge strides. New York City has adopted a stretch code, which is going to have to force people to use better specifications, and that's kind of what's beautiful about these groups and these practitioners that are getting more educated and aware of it. We're really pushing and trying to drive the officials to kind of change the policy, but it's really hard to talk to a client when what they're buying is fine for code, and they're saying, why should I have anything better? And you said, well, you make the argument about comfort and about all the various things of Passivhaus, but at the end of the day, a lot of people, they make their decision based on cost, and it's short-term thinking, and that kind of short-term thinking is also kind of runs through the way we have developed codes in the past. So if we can try to get over this hurdle, and I think you guys have probably do a better job with your clients than I do of trying to explain the benefits of why we should build better, and that's really, it's its own complete own talk, and I think that's our biggest hurdle. I know windows are hot, but really trying to change the mindset of how to build better and why to build better is really a key thing that we're missing in many parts of the country. So I'm gonna go through to these case studies, not get off my soapbox for a little bit. I wanted to start with a Passivhaus curtain wall. I don't know how many commercial projects people are doing, but I always like to start with this to show that this is possible, right? Passivhaus has house in the title, but it really can be at any scale. Like look at the projects here, and the Passivhaus level components that can be incorporated into that. So same thing with daylighting, it can be incorporated at any scale. So this is a system that is, a dry glaze system, meaning it has a pressure cap that overshoots the insulated glass panels. It It has a flashing system that is also insulated. And then the air tightness is made on the interior through a special gasket there. And I can give a close-up of the gasket. So these glass panes, if you can follow my cursor, sit on the edge here and on the edge here. And that weight of the glass is what creates the airtight seal. And then what's cool about this is that any water that comes in from that top pressure plate, these are your drainage channels, which are outside of your airtight envelope. So that's how that system works. And this is us putting it together. So you'll take these triple pane IGUs, this is a hip roof skylight, and we're placing them onto these pre-made transoms, and they have the gaskets there already, and the glass gets all set in place. And at this stage, it's completely watertight. So any water that comes off this glass is going to run into these channels and then out these weeps here. It's on an upstand, and this upstand here gets over insulated. So we're adding the mineral wool insulation, and then this EPDM membrane is actually glued to the gasket. So completely, if anything spills over the gasket, can run down this EPDM membrane right there. And this is kind of a look at how all those junctions happen. So these are the drainage channel, and this is an air channel. You can see the technician over insulating, putting a foam insulation in this gap. And then we're using stainless steel screws, which go through the pressure cap and into that bottom transfer. And that's really our thermal bridge. And the reason we use stainless steel is because it's less conductive than your typical screw. And here you can see that over insulated flashing, the eave condition. So that becomes part of the unit and gets fastened in the same way with this pressure cap, but it's insulated and drained all the way around. And that's how the unit would look afterwards. Looks like a pretty typical skylight, but this is at the Passivhaus in a variety of different ways. So this is probably more familiar building typology than that everyone's familiar with. Single family new build. Oh, sorry about that. Eek. Sorry, I have, when Google rings, it goes through my phone, so I forgot to mute it. All right, so this is a new build, single family residence. This is in Newborough, Massachusetts, climate zone 5. Pretty much going to the Passivhaus standard, although it did not get certified. You can see they have very large openings, so ready for these large glazing units to get put in place. Just to give you a scale, this is the size of one of the fixed units. So they're taking it off the truck and they're gonna put them in place there. We're not supposed to tell OSHA about this, but you get the idea. We have a variety of different units in this project. So some combination fixed glazing and door units. This is the entryway. So that's them bringing it in to the building. You can see that the sheathing is all taped for extra air tightness. There is an interior main air tightness, and I'll get to that area, but this is, an extra layer. All the tapes are seamed. All the seams are taped. And you can see here, there's that air tightness, and they're prepping the window to bring it in. Now you can see here that we're lifting the window into place, but what you notice here on this window is that this is just the sash. The frame is not on this. And the reason for that is we're gonna pre-install the frames. And the reason we do this is twofold. One, you can see the frame is way lighter, so we can handle it a little bit easier, make sure everything is square. Mostly for these larger units. On a smaller unit, you may not want to take the sash out because they do set it in the factory. And you don't want it to, it's sometimes hard to put it back, especially if you don't have a technician on site. This specific project, there was a technician flown in from Austria. These are Austrian windows, actually very similar to the SmartWin detailing coming out of the same factory, whoever was using that product. So what we're doing here is we're pre-taping these windows, and we're doing a blind tape method. So the reason for this is we don't want to tape anything to the face. It's got such a small reveal that for architectural reasons, we don't want to cover that up. So what we're doing is we're taping it before, and you can see we're overshooting at the corners, and then we're going to flip that tape over and tie it into our air tightness barrier. There are special tapes that are double-sided that can do this, but you can pretty much do that with any air tightness tape. you're just going to have to roll that over. It might be a little bit hard to work with, but you can do it. So you can see now we put that frame into place here. We can see that it's a little bit outboard of the sheathing, and the reason for that is we're going to tie it directly into our insulation layer. So now we put that the sash back in. It's a tilt and turn window, very large tilt and turn window. So you need special hinges for a unit this size. So once that's in place, you can see the tape sticking out here. That air tightness is going to get carried into the buck, and then this is going to get taped over there. You can see all the air tightness throughout the entire project here. Behind all the framing, so you can see it's completely continuous, and then your separate windows are punched in there and are going to get tied into that assembly. We can do fairly large openings. You know, large pieces of glass actually perform better than having a lot of different frames within the glass. So the more glass area you can get, typically is best. You can see that these steel columns are inboard, so no worries about thermal bridging there. And then this whole space is going to be a lift and slide unit with a large fixed pane, a slider on the left, and a door on the right. And we have prepped out the sill with sill flashing tape, and the unit's going to sit directly on that sill flashing tape. Because the glass is so high, it's about it's more than 9-foot window pushing against 10 feet. That is really the limit of these containers. So here we have a specialty container called a soft top, and it's this tarp that actually is strapped over. So this is sitting out just a little bit. It gives you a little bit of extra head height so that we can get this unit in there. So this is how high that glass is. And it comes not glazed because of the height restriction. So we just have these glass panels that we're pulling out, and then we have to glaze it on site. So we have the frame in different parts. This is the technician from Austria putting together the frame. You know, the fixed large piece glass that you saw coming out of the truck, the sliding component, and the door here. This gets assembled, put into place, and then glazed on site. So here, the frame has been installed. The sliding sash is there for the lift and slide. And then we're craning that large piece of glass into place and glazing it on site. And there's the whole unit put together. So same detail as all the other windows, sitting proud of your sheathing layer. That large piece of glass is there, door, slider, everything installed. So now that we have all of our units in place, a couple fixed units, some operable units, some doors, we want to make sure that they're installed in the right layer. So here's a kind of close-up of it protruding past the sheathing layer. So you can see we're doing our weatherproofing. So we're keeping everything WRB, or keeping this layer of protection, which is an airtight layer, completely airtight. Our WRB is actually going to be our insulation in this case, and I'll get to that in a second. You can see on the bottom, we're insulating as much as we can below the frame. With these large units, we're using these steel clips outboard to kind of hold it in place. And it's also clipped back at the sheathing on the sides. And then we're surrounding insulation around the whole frame, as well as behind this tape, any gaps, there's insulation as well. And here's the WRB / insulation layer. So it's a wood fiber insulation. You can see it's tongue and groove, and that's going outboard just as a layer of continuous insulation that's going to meet up with the window. The bulk of the insulation on this project is inboard. It's about a 2x10 wall that's going to be dense packed cellulose behind an air barrier that you saw previously. So this is just an extra added continuous insulation component outboard. And you can see it's coming right up against the window frame. So right in line, just about where that glass is. So on our standard, textbook example, this is the glass is sitting within an insulation layer right there. And then that's the whole building being wrapped in this insulation. You can see that it's got the strapping here, and then they're gonna have this vented rain screen. This insulation has a paraffin, which makes it waterproof, so no additional waterproofing is needed. And then they're just gonna put on this Shoshugi bond siding here, very pretty, coming horizontal. And you can see the window is specially detailed so that the edge of that frame is in line exactly where the siding meets. So you get that flush kind of detail. And then the finished project here, again, seeing the snow build up on the windowsills is always a great sign. Same thing, if you see condensation on the exterior of your windows, usually means your windows are doing the same thing. Don't want to see it on the inside, but on the exterior, it's the same process, that the heat is not getting to that exterior pane. I've got a bunch more case studies. I'll just roll through them. So I wanted to show you different construction types and different operations. So we have a CLT construction, which I think is becoming more prevalent out west especially, but this was the first one in New York State that was residential. So CLT with large sliders. They have these tilt and turn windows again. Here's an image of tilt and turn all wood windows. Again, a similar detail where this is actually sitting in the CLT layer. So the width of the window is about the width of the cross-laminated timber. So these are solid wood panels. Yeah, cross-laminated timber, meaning that it's a full wood panel. So this is doing all the structure. So it's not a timber framed wall. These are solid pieces of timber that are laminated together. This is, I don't remember the thickness, but they range from 5 to 7 inches. I believe this one was 5 inches, but I don't remember off the top. So this is kind of going back to that point now. If you want this detail where it's flush with the CLT on the inside, you obviously are not having it directly in your insulation layer. So what we did here to compensate for that is you can see that this window is sitting pretty much flush in the structure. So it's a little bit of a thermal bridge, but you have this routed lip around the window, and the CLT is now covered with this airtight membrane, which is its primary air tightness. It's taped at all the seams. It's also your weatherproofing. And then you can see they're putting this thick, beefy board insulation outboard wrapping around the whole unit. So this is what it looks like with the insulation wrapped around the entire building. And what you see is that they actually over-insulated the frame with the insulation, so the insulation is running past. And since it's an in-swing window, it's okay. That tilt and turn is coming inboard, so you don't have any interruption outboard. You can see that there's cross battens here. The reason for that is that in this case, the siding is vertical. So they have this vertical siding.
Is that duct on the side?
Yeah.
I know it has nothing to do with windows. It looked like a metal duct.
This metal duct. Yeah, that's an exhaust duct there, and they have a break on the inside, but it is a thermal bridge.
Okay, just checking.
This got modeled, but again, it didn't get certified. Just because on the residential scale, this was an architect's house. He didn't go for the full certification. He really wanted to explore with different building technologies. So the CLT is actually versus his carriage house, which is a traditional stick frame. And you can see a French door scenario here. And what he's doing is trying to compare the two construction types, both in cost and performance. So he's got monitors in both roof assemblies. And I haven't followed up in a little bit to get that data, but I should, because it's an interesting comparison. And we went over when we did the blower door here, is that anytime you have a French door, it's very challenging to get this completely airtight. Right at the seams here and the top, it's very hard to keep that tight. So there is some air leakage in these French doors styles.
Right, you actually talked about that a little bit, if you don't mind me. You talked about the triple seal process. Now, are regular windows often rated for wind tightness, and how important is that for just a
Yeah, they're rated, the NFRC rating does have like water permeability, and they have to do those ASTM tests. So typically they have a level of performance. It's not the same level that you would get. Like for instance, if you had it to, and I'll get to this in I think the next example or two examples is our traditional sliding windows. There's no way to make those airtight. They're not going to be able to pass a blower door test because the sliding component is never going to be a gasket. It's going to be movable. So same thing in this scenario where these two gaskets, you can see that you have the triple gasketing, so you can see the ridges all around. At the transformer where they meet, those two gaskets are relying on each other at the bottom to do it, and there's no way to really lock it into place so that it's completely airtight. Maybe I know Alpin, you guys probably have a lot of experience with certifying windows and having a pre-Passivhaus versus a Passivhaus certified product. What the difference is there. You guys can probably speak to it better than I can.
Well, I'll say quickly with respect to air tightness. I mean, it really is going to be the same whether it's a Passivhaus certification for certified project or not. Really, for us, what makes the difference in terms of making the certification or not is more relative to insulation, because the way that our window products, or a Passivhaus window product as we know it, has air infiltration numbers, it doesn't really make a difference. What makes the difference is how you insulate that window versus the air infiltration. We're going to achieve those air infiltration numbers regardless of whether it's a Passivhaus certified version of our window or not.
Right. Because that's a separate testing and procedure that you've had before, just for the ASTM tests. So
absolutely.
Yeah, exactly. So one thing that is interesting is when you're certifying a window with PHI, if you're certifying just one window type, all they require is for you to do an energy model. They don't require any physical testing. That does change if you're starting to go for a window system. So they're really caring about frame performance, spacer performance, how it's working thermally. If your window is completely airtight, you will never pass the blower door test, and you'll never get certified. But it is interesting to note that their main focus is just on the thermal portion of that. Air tightness, it has to be done by the manufacturer. So yeah,
correct.
Yeah, exactly. So just going through the details of the big lift and sliding doors, again, having that, finished CLT, meeting up with the window edge. So this project is just pretty much all variations of wood, right? You have wood windows and doors, you have a solid wood wall, then you have wood fiber insulation, and then you have wood siding. So I like showing this because it's, there's a lot of buzz around wood as a renewable resource, as kind of a means of, carbon negative. It's a carbon sink. So really interesting things with these technologies. There's the south portion. Going a little bit further north, again, looking at a snowy area. This is in the Catskills in Elko Park, not too far from me. We just did kind of a large renovation where we took this old cabin. We pretty much wanted to bring it up to passive standards and completely remove this wall. So, add as much glass as possible. This is southern facing, pretty much due south. So we wanted to add a complete glazed system there. So you can get these Passivhaus windows in obviously different shapes, sizes, coordination. This is another Austrian manufacturer, Optowin, and you can see that they actually have built-in insulation around some of their frames. So some wood fiber, this is part of the unit there. Didn't have a big crew. It was only 2 people trying to lift this window in place. So we have, come-alongs can do a lot for you. So we're slowly inching this window up into place. We've got the full kind of faux curtain wall with a large fixed, a door, another window, everything in place. Again, exterior weatherproofing taped together so that no water or infiltration is coming through. And then on the inside, you can see, not there yet, but all this interior insulation and air tightness will get connected right to this system. SIB Construction, I don't know how much you guys do out west, but it's fairly popular here, or starting to be a little bit more popular. You have transparency through this long barn-like building. They even have an area for a skylight to go through the entire building, goes up, over, and around. And then you can see just the amount of glazing here. And this is due south. So right away, when I say this is south, you guys should be thinking, well, you might have overheating problems. So the idea is to shade this area, these areas as much as possible. So again, they're using these large lift and slide doors where they have the operable sash removed and they pre-tape. This is that blind taping method again. You can see with the bunny ears, because they're going to tape this. Once it's in place, it's going to be very hard to tape to the face. So they're bringing it in, screwing it into the structure. It's a heavy timber frame construction here, and then the SIPs are outboard there. And you can see the SIPs are taped at the seams as well. And of all the doors being put in place. And here's that southern wall again. And you can see that these are all actual louvered shading units. So these all turn up. So you can get that full transparency. But again, you had to have a lot of shading because this has a lot of exposure and no overhangs. So this is the compensation for that. Skylight, again, has that very low solar heat-gain glass. But I fought tooth and nail with the architect to get shading. I lost. They're going to have some overheating there for sure. I'm sure of it.
There's a lot of barns. Is that just what people build now?
Yeah,
super cool projects.
I can't believe, like, now that I'm looking at it, I'm like, wow, everything just looks like a barn.
Everything's a damn barn. Okay, it's just an East Coast thing. Yeah.
No,
Yeah.
it's the modern of the moment, though. Everyone loves the simple gable.
It's the modern. Yeah. It's good for
Seriously.
Passivhaus. It's, brings us back to the German early days.
Said.
Exactly. One of those images actually looks like the Passivhaus logo from the side, so I like using that.
We should. That's good. Maybe laugh.
Yeah. Well, here, so I got two different typologies real quick, and then I can open it up. So I've done a lot of my work in the city, and specifically in Brooklyn. There's been a huge Passivhaus movement there. And so we've run into these historic retrofits and kind of coming up with a solution to how to make a retrofit project Passivhaus when you have these strict guidelines. So here we're installing in a landmarked area these landmarked approved Passivhaus windows. So what's cool is this is non-Passivhaus, this is Passivhaus. Not the enclosure, just the window. So you can't really tell the difference. So we've simulated the entire look. So the depth of the transoms, the muntins there, these are simulated muntins, so we get that look. But these are still triple pane units, and how we do that is we call simulated double hung. So we have a operable bottom sash, which is your typical tilt and turn window, but this top sash is completely fixed. So this will in-swing inside, and this stays fixed. And this is what it looks from the inside. You can operate these windows in a tilt and turn fashion, and this stays fixed. So this has been a kind of a typology that's kind of been buttoned down now, and it can be replicated fairly easy from project to project. So we've done a bunch of different ones, and they can manifest in different ways. So for instance, it's this classic brownstone facade with these bay features. And one way to do it is they replace the whole bay with a passive assembly. So this is an insulated panel that mimics, this kind of condition here. And then the bay windows, these are two fixed windows with an operable window in the middle, all triple pane glazed, and kind of picks up the historic language of the neighborhood. These are not in landmarked areas. Otherwise, you would not be able to have this modern door. Same thing here, you would need to have the simulated double hung. So what they did instead was keep kind of historic language, just put a more modern open window, which is actually better for the window value. And then they wanted to keep that French door kind of aesthetic. And this is what it would look like in the front, from inside, where the windows on that bay side are completely integrated into your air tightness. So this is all insulated, furred out from the brick, about 12 inches. And that brick is sitting in there, and behind this is dense packed cellulose, and these windows are integrated directly into those layers. And then going back to curtain wall, this will be my last kind of run through. You can do Passivhaus certified curtain walls with Schuko or Rainier's or Lamelux, different manufacturers, all European, but are available in the US. How they work is, they have this pressure cap that holds the glass into place and is fastened back to a mullion system. Some new technology that's on the way is this, there's completely thermal bridge free installation. So this is a wood mullion system. You can see that wood mullion that actually has these pieces of fingered plywoods that are siliconed to this glass edge. And what happens here is these get screwed in on site. So this component comes, they get screwed in, then the backer rod or insulation piece, and then this is a silicone joint. So there's no, where you saw before where you had those stainless steel screws going through and being a thermal bridge, there's no thermal bridge here. It's completely over insulated. So no projects yet in the US, but it has happened in Europe. On a more commercial scale, this is a photography studio, again in Brooklyn. We have a curtain wall condition, as well as a curtain wall roof or skylight. And again, we're putting it in piece by piece, so it has to get glazed on site. All the aluminum transoms are put in place with cranes and forklifts. All the gaskets are prepared, and the glass is going to lay right on top of that. And we're dropping the glass from a crane into each space. And then it's very much like the first system I showed, where the pressure caps get put in place, the over insulation happens, the insulated eaves, all that. Here's a cool tool, the spider crane, really good for heavy pieces of glass. It's got a robotic arm that will actually shift different angles, so we can actually kind of tilt it, pull it through the opening back down, because it's back of the building and we had no street access, couldn't get a crane over the top. So you can see if it's triple pane on these things, it's actually structural, so the technician can actually stand on the glass. And you can see Jens filling in the insulation on the edge here, over insulating that frame. And you can also do any maintenance that you need by walking on this glass. And again, the pressure caps would be put into place. And that's about the size of the unit. And it's got an operable sash motorized here on the top. So this would actually open up to ventilate. You wouldn't want to do it when it's raining. So there is a rain sensor that will close the window automatically. And you get kind of this beautiful day-lit studio. So the photographer uses this to light the space. So you get a lot of natural light for shooting. And these are, this is not Passivhaus. This is not a Passivhaus project, but this is a Passivhaus system. So if everything else was made to Passivhaus standards, you could theoretically do it depending on how much heat gain you get through this.
Are you saying, you had said that you could walk, obviously you could walk on those those windows. Could you walk on any triple pane window, or is that just these windows?
Yes, definitely talk to the manufacturer, because you can't.
I would highly not recommend that.
Yes. This is specific for this skylight. And because the glass buildups are laminated, that it's super strong.
Yeah, absolutely. Thank you for that.
Cool.
And this system too, they only recommend walking for maintenance. So like if you had a party, you wouldn't want to be on here with high heels. It's not recommended. So yeah, that's it. So I'm happy to take any questions. But that's what I got.
Thanks so much, Ben. I guess I'd love to start off with a question that's kind of more about the window market. Most of your projects are in a warmer, more temperate climate zone than a lot of us are operating in the Rocky Mountain West. Alpine, I know, has a lot of great options in climate zone 5. I'm wondering what perhaps you are seeing is happening in colder climates for 6 and 7.
Yeah, that's a great point. Actually, a lot of the windows that I showed in the case studies are rated for the higher climate zones. So those are Passivhaus level A frames. Both the OptiWin and the Buiso are certified, and what other ones did I show? I'll have to go back and go through, but those are both A, and the Lamilux, which is that commercial system, also can be an A. So you can use them in most climates.
Great.
But it is a good question in terms of the market. So for the first time, I've had a traditional window manufacturer, US, approach me to see what it would take to get their windows certified. And they actually do projects all over the country. They have a bunch in Aspen, in Colorado, and they've had clients that have come to them asking about Passivhaus. Now, they don't have anything that can perform to that level, but they're engaging to see what it would take to develop, a climate zone 5 window. So maybe not the 6 and 7, but just to see if they can get their Hudson Valley and New York City and Boston market covered.
Do you think that the sources then for sort of cold climate windows are still probably European, or there are new Canadian manufacturers that we could consider? Or I know it's just been really challenging for ones that are PHI certified. They're in zone 5, it's much easier.
Yes, yeah, I still think most of that's coming from Europe, although there are, like I said, it's been the last couple of years that there's been movement. There's been, Alpine, you guys have done great work out there. Up in Canada, Cascadia, you've got an East Coast manufacturer, Wythe Windows, that just came online. They're going to start coming in at the low-hanging fruit. I think it's going to be a little bit of time before they really push through to get everything certified for all climate zones.
And by the way, as a U.S. manufacturer at Alpine, we welcome that, because we feel that all boats rise as we get more competitors into the marketplace. It pushes us to be better and more price competitive. And I'm all for, the Europeans make great windows, but we're all for the idea of having U.S. manufacturers and having, competitive conditions here where you have choices here. And raise the level of visibility into these products manufactured here in the U.S.
And Craig, can I add that one of the things that they made windows really difficult windows were one of the most difficult parts of Passivhaus. They didn't exist when they created the standard, frankly. They had to make their own for the first few Passivhauses. And the idea was to get manufacturers to rally manufacturers to create and provide better products on the market and make them cost competitive over time. So, watching how Alpine, how you guys embraced that process has been really outstanding for us, especially in the domestic market. So, one of the questions I have is, Ben, what would you like to see changed? Where do you see this? There's all sorts of kind of new theories on how to deal with these problems that PHI has basically handed us and said, you guys, good luck, right?
Yeah.
Some of
Well,
these
the vacuum glass, I'll believe it when I see it. I've asked a lot of manufacturers to give me samples, and no one can do it yet. So I think it is on the way, and I think those people who went to China for the international conference got a firsthand look at that. And I think, unfortunately, I think China is where the big innovation is going to happen, and we're going to kind of follow that market. I would love to see, and I couldn't agree with you more, Craig, that it's really the U.S. has the potential for such high quality work and can really produce these windows. I don't think it's the capability. There's just, these companies haven't been pushed on the demand side. So as things are going to start coming from China that are really pushing the bounds, like this vacuum insulated glass panels, that's going to be a game changer. Am I excited for it? I don't know, because it hasn't been tested. I think it'd be cool to check it out and see how it works long term.
For sure. What I can tell you is that it is a very viable solution. It just is at the point in such an infancy stage where it is very, very expensive at this point. But I think they have a great viable solution long term. They just need to figure out how to get the price down. And relative to China, there's just over 40 Passivhaus window manufacturers, certified PHI window manufacturers in China now. If I'm not mistaken, I may be off on that number when I last talked to Bronwyn, but they're embracing it massively. So we may see this massive influx of product coming to the US. Obviously, as a manufacturer, I hope not. I'd much rather see our manufacturers here in the US embrace the standard and start to make products that are usable for folks like everybody that's on this call, so that we don't have to, utilize that embodied carbon to transfer products all the way over from China to get here.
So Ben, can we transition a little bit from that conversation, just installing windows today? The complexity of windows is not just having it modeled, but the logistics of getting the window to the site, getting all those things set up, getting it installed properly. If something goes wrong, having somebody there to support it. Those complexities, what's your view on how that needs to be improved or is in transition?
Yeah, that's a great point. And I think I've had a unique view where I've been on kind of all sides of this coin and like dealing with suppliers and manufacturers from the source, trying to get it to site. So that whole process is very laborious. It's not easy. It's not straightforward. The timing is a crapshoot, and getting the container to a hard site is very challenging. So it's not like especially when you're importing the units from overseas, it's not like buying from a domestic supplier where they have the trucks and the equipment and the technicians there. You're relying on so much knowledge from the person you're buying it from to tell you how the container arrives, what you need to do to unload it, what the conditions are on site, and then you have to have on-site installation support. So I think this is where I would see a huge gap in the market, is that if you have American manufacturers, then you can have local support. So I totally agree with having this localized economy, because it's really, from an environmental standpoint, it makes sense, but also from just a servicing standpoint, to get the service to do these installs is quite challenging. So as you can see from a lot of my examples, and this guy here in the picture, he's a technician from Germany that flies around the world and installs these, high profile skylight systems. And it's crazy that he's one of the only guys that can do this, and the cost for that, the environmental implications. So, getting local people trained on how to kind of install things a little bit differently, considering they are, it's not your flange window that every builder is accustomed to. These are a little bit different. Mm-hmm. But yeah, so it's just getting that local support. Did you want to jump in, Craig?
No, I think we're pretty much right on the same page with that.
Well, it sounds like we really need to kind of continue to, as we build our market in the West, like we're able to create more demand for the window companies to be able to respond to. I realize we're such a small market. There's so few of our residential projects and new construction and renovation that are calling for Passivhaus. And then of those, the ones that kind of go all the way through, it's just a small piece of the market. And we'd love to be able to source, 6 and 7 windows stateside. That would be excellent. It's terrifying, I can tell you, to put your trust in something that's going to come over on a container ship, and get dropped. And there's not only an incredible investment in that whole delivery, but there's such a disconnect in the whole process, as Ben was alluding to, that like as professionals, like the whole process is like, it's just nerve-wracking. And having, then long-term service too is another issue. So there's a tremendously like ripe market here for this, but it's just so new. It's a really small one as well.
But it's growing, Lindsay. It's growing fast. And we obviously, you guys see different parts of the country as we do as well. And codes changing. We see certain incentives being put in place to build passive, whether it's at the single family residential level or moving into multifamily. That's where we're seeing the biggest growth is in multifamily, and totally. We start adopting that kind of thing. It's attracting. That's when you start to get some buzz and you get some more players involved, and that's exciting to see. And that is certainly going to see. What you mentioned, wide windows. That's a great example of somebody that has been in the passive house market that saw an opportunity to enter into the window portion and has done a great job. And there's going to be more people like that, no question about it. And I think it's going to be helpful for all of us here.
Yeah, it is a movement that has been steadily growing. I remember hearing stories from Ken in the early days where it was just him and a couple of people in a room, and now it's a national kind of phenomenon with changing building codes. And we've actually changed the building code in New York City just from our local grassroots group. So I can't stress enough like the important work that you guys are doing just for meeting up, speaking with each other, learning from each other. Like that's what's great about the community, is that we're all very willing to share and help each other. And it's something that we need to just keep on pushing, because the more people who are aware of it and educated in it, then, the more choices you'll have, the easier it will be to find people who know how to deal with, European windows or high performance windows or just passive house in general. So I commend everyone, and I appreciate you guys inviting me for this talk.
So Ben, let's get you out here sometime. We obviously we have an interesting history on this, but you are going to be out here. I know that. So
Yes.
you're out
Yes.
here. Let's put something together, maybe with Alpen, and and really get people to understand like how transformative this is in the building process.
Yeah, I'm all for it.
The skiing's a little better.
My mountain's not even 3,000 feet high.
Obviously, we it goes without saying, Ben, we'd love to have the opportunity to host you at our manufacturing facility, and really appreciate your presentation today. Fantastic job.
Great. Thank you, guys. Yeah, I'll definitely take you up on it.
And there's good beer here too. So
I know.
So we'll get you to Montana too, Lindsay. Ben, road trip is asked up to Montana. And
yeah, there needs to be like a Western tour, I think.
it's a road show.
Do a Rocky Mountain
Western
road
show.
trip.
Yeah,
that's
Yeah.
right. Right.
Somebody's got to have a van out there, right?
Well, and I want to
I
make
think
sure if anyone has questions, we have time to ask them. But I'm actually kind of curious, Ben, like what would you tell a designer or a builder that wanted to do a passive house, in a challenging climate? What kind of resources would you point them towards? Or, whether it be organizations or databases, or, when someone's going to do a deep dive into learning about windows for passive house, how do they get started?
Yeah, so the PHI has a pretty good component database to filter everything that it's certified and their level. And I don't know if you guys have that sourcing on your website or somewhere, but that's a pretty good home base to kind of look to see what is actually certified. It's by manufacturer, by country, and by class, so you can look at all that information. I could share with a follow-up that link, but I'm sure you guys are familiar with the PHI site, or some people are.
Mm-hmm.
Yeah.
Yes.
So maybe we'll share that with the group, and then these networks. So NAPHN, the people who do the trainings and the conference, that network really keys you into people all over the country doing different projects. So going to these conferences is a great first step. They're not always in New York. Some of them are closer to you guys. They did one in California. I believe even the 2021 might be in California. So and then hopefully maybe Colorado, Denver seems to be a hotbed. Maybe you guys could host a conference there. That would be amazing.
It'd be nice to not have to travel.
Yeah, but it's a great way to meet people, and then you meet people doing different projects.
For sure.
I think it's
been pitched to take the conference to Denver for sure. So that means you'll be coming out here to volunteer.
I will happily volunteer out there. Yeah.
Any more questions down?
Yeah, I have a question. There was about 5 slides back or so. You had shown a window with a thermal that one right there. That seems like now that's a passive house certified window.
This is a curtain wall system.
Okay.
So, yeah, so this isn't. Let me get. Yeah, it's just a sample. I don't have any projects to show, but
right.
So you have this mullion system. This is interior, right? These triple pane IGUs are actually glued to this piece of. It's in essence like a plywood.
Yep.
And that plywood is kind of. Can you see me?
I can see you.
Yeah. So finger jointed like that.
Yep.
So they click into piece like a puzzle piece, and then in this small gap here, they're screwed into place. So this is screwed in place. After they're set in place, then someone comes back and glazes this on site. So it's wet glazed. You
right.
Add
well, super simple method, but I guess yes, it's the curtain wall, so it's non-operable. Because that right there just seems like too simple to even.
It is a cool concept. I had one project go very far in trying to get this spec'd. The problem is when you start talking about loads, there's a lot of restrictions. Just because, like, if you have any seismic activity or wind activity, all the structure is put on this on this joint here. So that's really the key of the whole system. There's nothing else holding it in place.
Right.
But I'll maybe share a link to there's cool projects in Austria and Germany that have used this system. So it's cool.
Hey, thank you.
Yes.
No problem.
Nice job, Ben.
Happy to do it. Cool. Yeah. So I'll share my my contact info with Andrew and Lindsay. So if you guys have any questions, or do you find yourself on the East Coast, I'd be happy to talk through things, meet up, show you some projects that are out here. Yeah, thanks you guys for having me.
Absolutely. Last call for questions from anybody?
Thank you, Lindsay.
Thanks for joining us tonight. And we'll be having another meetup in early February. As always, we hope that maybe you bring a colleague or a coworker or a friend or just interested person and invite them to join us as well and spread the word. Ben, thanks so much for joining us tonight. It's great to just spend some time talking about one major component of the whole assembly system. And I really like this idea of everyone starting to think further about windows and not just being what we look outside of our houses in, but part of our heating system. And I know when I talk to clients about, the value of their windows being a component of their heating system, I mean, it's rather obvious, but it really does seem to resonate with them. They think about it in a new way, and they also value that product in a different way. So we all get really excited about windows, and as designers, we need to know kind of all these different factors that calculate into, what can get certified and what doesn't quite meet the mark. So I really appreciate the deep dive. And you're welcome back to these meetings at any time. And Andrew, thanks for asking Ben, and we hope to see you at the New York conference in June.
Sounds good.
Yeah, thanks, Lindsay and Andrew, for putting this on again.
Absolutely, guys. We'll keep a watch out there for an invite for February's meeting. Hope you guys all have a great January.
Happy New Year.
Stay warm. See y'all soon. Bye.
Everyone.
Thanks.